Okay. Yeah. So in this video, I want to derive the law of cosines. So we got some random triangle ABC. The sides are labeled, the opposite sides are little a, little b, little c. And the goal is to come up with this equation here. It looks an awful lot to me like Pythagorean theorem modified a little bit. Okay. So that gives me the suggestion to make some right triangles and try to use Pythag. So I'm going to call this part capital H, or not capital H, lowercase h for height. Over on this side, I'm going to work with angle C because angle C comes into play here. So over on this triangle on the right side, the right triangle on the right, I'm going to refer to this bottom part as x, which would make this bottom part b minus x. Now I know I need cosine C involved somehow. So let's look at what cosine C would be. In this right triangle here, cosine is the adjacent side over the hypotenuse. So it's going to be x over a. So if I wanted to, I could isolate the x and write that as a times cosine C. We could do that with the h too. If I look at sine C, that's the opposite side over the hypotenuse, so it's h over a. And then if I multiply that over a sine C equals h. Okay, so I've got a way of writing x here. I've got a way of writing h using the letters in black. I would also know that this side here, b minus x, is really b minus a cos c, so that works too. So let's actually do some Pythag, because this looks like Pythag. So if I take the triangle on the right side, I've got c squared equals b minus x squared plus h squared. Okay, so let's work some of that out. So on this side, this is going to turn into b squared minus 2bx plus x squared, right, when I FOIL out that b minus x times b minus x. And then I've got plus h squared here. And b is already a letter. The idea is that I'm only going to use black letters here, the stuff that's in black, and try to get rid of everything that was in red. So I want to end up with little a, little b, little c, capital C. That's the only angle that I've used. So this is going to be b squared minus 2b. X is a red term, so let's replace it with stuff that we can use. So a cosine capital C plus, and then x squared, which is a cosine capital C squared, plus h squared. And h we know is a sine capital C squared. So if I work this out a little bit, I got b squared minus 2ab cos C plus a squared cos squared plus a squared sine squared. So I can take these last two terms. Let me first write the first two. And I can factor out an a squared, and I get cos squared capital C plus sine squared capital C. And we know that cos squared plus sine squared is always 1. So this just turns into a 1 right here. And I've got 1a squared plus a b squared minus 2ab cos C. So this becomes a squared plus b squared minus 2ab cos C equals little c squared. That's just bringing this down. So this right here is the law of cosines. And it's most useful when you either are given all three sides and you need to find a missing angle, or if you're given A and B and capital C and you need to find a third side. So if you're given like capital C here, then this side is little c. So one of these would have to be little a and one of these would have to be little b. So you're given SAS info. So this is useful if you have SAS info, or if you have SSS info. Those are the two times that this comes in most handy. Okay, hope that helps.